everybody. So we're at Jacksonville University. We're going to be measuring the pH levels of our St. Johns River. When scientists measure the pH of a solution, what they're measuring is the concentration of hydrogen ions and hydroxide ions. Recall back to chemistry class, hydrogen is represented by a capital H, and to make it an ion, you add a positive sign after it. Hydroxide ions are represented by capital OH with a negative sign after it. So let's look at the pH scale. It goes from 0 to 14. When you have higher concentrations of hydrogen ions, you're going to be on the acidic end of the scale and below 7. If you have higher concentrations of hydroxide ions, you're going to be on the alkaline or basic end of the scale, and you're going to be above 7. When you have equal amounts of hydrogen ions and hydroxide ions, or pure water, you're going to be at a pH of 7. The scale is logarithmic, meaning that as you move away from 7 to the extremes, you're going to have 10 times more ions than the number before it. Let's look at some everyday examples around your house to put the pH scale into perspective. If you're an aquatic animal or plant living in the river, you don't want your water to be too far on the low end or too far on the high end of the pH scale. You really want your water to be a pH of around 7. So now we're going to test the pH levels of our St. Johns River. I'm using a Lamont wide range pH test, and what that includes is a color comparator. So this scale goes from 3 to 6.5, and then I have another scale that goes from 7 to 10. I have a reagent that I'm going to add to my river sample in my little vial here, and this reagent will bind with the hydrogen ions, and it'll form a color, and then I'll use it to compare it to the colors on the color comparator. So let's go ahead and test our pH levels. So I'm just going to add 10 drops of this reagent into my jar. All right, put the cap back on both of these items, and then I'm going to mix for 30 seconds to a minute. We've inverted our solution for about a minute, and the color is a greenish color. I'm going to take my color comparator, I'm going to put the vial in one side, and on the other side is my scale for my pH range, and this one goes from 3.5 to 6.5. So I'm going to take a look to see if the green matches up with any of the colors on this scale. And it doesn't look like it, so I'm going to take the second scale, which goes from 7 to 10.5, and it looks more like our green color matches up with a pH level of 7, 7.5. So today, May 5th, 2020, our pH levels of the St. Johns River is around a 7, 7.5. So why do we care about the pH levels in our St. Johns River? Although some organisms have adapted to live in more extreme pH environments, most aquatic organisms require water to be between 6.0 and 9.0 pH to be healthy. Frequent changes in pH or sustained levels outside of the optimal range can cause health issues, reproductive problems, and eventually death. Even small changes in the pH can drastically change the biodiversity of an aquatic habitat. pH levels in our river can change naturally through the soil composition, the bedrock of the region, and the rate of decomposition. Human activities can change the pH levels through chemical dumping, acid rain, and increased concentrations of atmospheric carbon dioxide. Our water systems, specifically the oceans, are the largest carbon sinks found anywhere on Earth. Carbon dioxide is a gas that readily dissolves in water and is one of the concerns of scientists when studying climate change. High concentrations of dissolved carbon dioxide results in ocean acidification. Lower pH levels of the oceans slows the growth of calcium carbonate-based organisms such as oysters, and under severe conditions, it can dissolve shells faster than they form. St. John's Riverkeeper is raising awareness of local impacts caused by climate change through our River Rising campaign. Issues such as dredging, stronger, more frequent storms, and pollution from more frequent flooding has led to an overwhelming need for more resilient policies and updated infrastructure. We are a part of a new coalition bringing together dozens of groups focused on this issue, and this summer our advocacy team will launch a new podcast-style discussion of resilient solutions from all over the world, nation, and state, looking at rising waters and climate change with a focus on the St. John's River. Check out our website and see how you guys can do some pH tests around your house with various items in your kitchen using an at-home pH indicator solution. Thanks for joining us today to test the pH levels of our St. John's River, and we'll see you again on the river soon.